Before Python, before JavaScript, before C, before any programming language existed at all, someone still had to tell a machine what to do. And the way they did it will genuinely surprise you. Most developers today take languages for granted. You open an editor, type some code, hit run, and something happens. It feels almost effortless. But there was a time when none of that existed. No syntax, no compiler, no IDE, no editor. Just raw electricity, physical switches, and human beings who had to think in ones and zeros, manually. In this video, we are going to go back to the very beginning and walk through how the first programs were built before programming languages existed. To understand where programming started, you have to understand what the earliest computers actually were. They were not the sleek machines we use today. They were room-sized collections of vacuum tubes, wires, and mechanical switches, each one representing a single binary state. On or off, 1 or 0. That was it. That was the computer. And to make one of these machines do anything, you had to speak its language. Not Python, not assembly. The actual language of the machine itself, raw binary. Sequences of ones and zeros that directly instructed the hardware what to do. This was called machine code, and it was the first programming language that was not really a language at all. It was electricity. Writing machine code by hand meant knowing the exact binary representation of every instruction. And if you got one bit wrong, the entire program failed. No error message, no stack trace, just silence or chaos. This is where punch cards changed everything. Instead of manually flipping switches, programmers could encode instructions onto physical cards, each hole representing a 1, each blank space representing a 0. Stack the cards in order, feed them into the machine, and it would read the program mechanically. This was the first time a program could be written, stored, and reused. The punch card was the original file system. But the most remarkable story from this era is one most developers have never heard. In 1945, the United States Army built ENIAC, the world's first general-purpose programmable electronic computer. It weighed 30 tons. It filled an entire room, and it was programmed by 6 women: Jean Jennings, Frances B. Loss, Betty Jean Jennings, Ruth Lichterman, Marlon Westcoff, and Frances Holberton. There was no programming language. There was no manual. They were handed the machine's wiring diagrams and told to make it work. They programmed ENIAC by physically rewiring it, reconnecting cables, flipping switches, reconfiguring circuits for every new program. No keyboard, no screen, just logic, wire, and an extraordinary level of precision. These 6 women did not just program the first general-purpose computer. They invented what programming was. The concept of breaking a complex problem into sequential logical steps, what we now call an algorithm, was something they developed practically, by hand. The next leap came with assembly language. Instead of writing raw binary, programmers could now write simple human-readable mnemonics, ADD, MOV, JMP, that a program called an assembler would translate into machine code. It was still incredibly low level, but for the first time a programmer could look at their code and actually understand it. It was the first abstraction. And abstraction is what all of modern programming is built on. From assembly came higher-level languages. Fortran in 1957, COBOL in 1959, C in 1972, each one adding another layer of abstraction between the programmer and the raw machine, each one making it possible for more people to build more things with less friction, until eventually someone could open a browser, type a few lines of Python, and build something that reaches millions of people, without ever thinking about the binary underneath. Every framework you use, every library you import, every high-level language you write in, it is all built on top of what those first programmers figured out, with nothing but electricity, logic, and wire. The foundation was harder than anything we deal with today. There were no Stack Overflow answers, no AI to debug your code, no documentation, just the problem and the machine. And they built it anyway. Every line of code you write stands on their shoulders. So I want to ask you, what do you think is the modern equivalent of rewiring a computer by hand? Let me know in the comments. If you found this helpful, make sure to like, share, and subscribe to see more videos like this. See you in the next one.